Okay. Okay, so there's a little bit of difference in this grading schema than it was in the other one. I did 25, 25, 25 for 100, 25. So like 4 25s. This one is 5 20s. So you have 20% based on labs and assignments, 20% on written final, 20% based on a skills final, which you guys have not experienced yet. I'll explain what that is in a minute. 20% based on weekly exams, same type of thing you've done, 20% based on quizzes. Those are those Cengage quizzes you guys are familiar with. So a skills final is basically we give you a list of things you need to do, and then you do it. That's all those are. But basically, it's you proving that for these last 3 classes that you were paying attention and that you can actually do all of this stuff that we walked you through. I will do a short example because you guys have not done a skills final before, just to walk you guys through and show you what you're supposed to do. I'm not just going to be like, here's a piece of paper, do the stuff on it, because I always hated it when my instructors did that. So we'll do kind of like a mock skills final so that you guys can see what that is. So next on there is we have our first group presentation that you guys will be doing during this class. Because I had so many problems with people making up their minds on groups last time, I am auto assigning groups based on random number generation. I will send people the assignments just so we can get it done faster and people can start working on things. So on the schedule, let me share your visual calendar here. Okay, can everyone see that okay? Do I need to blow it up bigger? We all good? Thumbs up. You can see it. We're good. We're good. Okay. All right. So you can see the visual calendar is just done like our regular ones here. But if you look on week 4, you will see an ethics group presentation. Now, it's not going to be like your capstone project, which is got a whole bunch of rules and stuff in it. It will count for the same amount of points that your weekly tests would. And then I will put together, you'll get a little paper with everything that you're supposed to do. Basically, what I want you guys to do is I will give you guys a bunch of different topics, and it will be about privacy issues. And you in your groups will pick one of these topics. You'll write a little paper, you'll give a little presentation. That's it. I would highly recommend just to organize your thoughts that you do either like a Google slideshow or a PowerPoint. It just seems to work best. You'll need to do the paper to turn in so that you can get your grading stuff. And then if you want to turn in the PowerPoint, that would be great too. But the PowerPoint's there so that when you give the presentation, you're basically going to share with us here and give a little presentation like I'm doing for you. And then what would usually works best with groups is we're going to do 5, since we have 15 students, we're going to do 5 groups of 3 randomly generated. I'll send you out which groups you're going to be in. At the end of this week, by the end of this week, I will give you guys everything that you need to do, your groups, your paper with your topics, your guidelines for your papers. And if you have anything that you need help with, just let me know. Let Zach know. He's your embedded tutor. Please make sure you talk to him. He's got his own channel and he's really great to get information out of. Yeah, you can do a group Google Doc. That's actually one of the best things that I ever did in group projects. Because then you don't have to be like, okay, this version, this version, this version, and then just make sure that you have the same version that you give me, because I don't want like 3 different versions for the same group, if that makes sense. So, okay, looking at this visual calendar, are there any questions about anything on the calendar right now from you guys? Okay, I'm going to assume that's a no. All right. So those are the big differences on 125 versus 125 and 123. This is just the continuation of 123. So we are doing the rest of the chapters in Cengage that you didn't do for the Network Plus. So I've hidden the top chapters you guys already did in the previous class. So you start off at chapter 7 and go down from there. And Cisco, I put the link just directly to Cisco's website. And make sure that you do, like there's a 123 and a 125, make sure that you're on the 125 for the content for this class. If you, for some reason, can't access anything, let me know. Remember that you have to, no cert exam on this one either. They used to do a Network Plus cert for this, but unless you're doing, I think it's an optional one that you can do, but it is not counted as the final. So no, we're not doing another cert exam. It's just a final for this one. And then I believe they can, I think you can get like a discount and take the Network Plus if you want to, like the CompTIA Network Plus. It used to be mandatory, but since we're security people, they didn't, it's not mandatory for us. It's the network group that they made that mandatory for. So you guys, you get certified ethical hacker and then security plus next year. But if there's any other certifications that you guys would be interested in, please let me know. I've been turning in some stuff for the like things that we can do to update cybersecurity program. So if there's anything you're like, hey, maybe we should, we would really like to see this certification added, let me know and I can say, hey, students have been asking about this one. So something to keep in mind. All right, any other questions before I move on to our slideshow and lecture for this evening? Anybody? No? No, okay. I think we're good. All right, so we are going to start with chapter 7 of the CompTIA Network Plus. Let me get this one set up. Okay, everybody see that okay? Okay, so here are the 4 basics that they want you guys to learn by the end of this chapter. They want you guys to know how to do the abstraction and the design of physical network architecture, describe and explain virtualization technologies on a network, summarize cloud characteristics, models, and connectivity options, and identify methods to increase network availability. I will say that they probably don't cover as many cloud options as there are because that just explodes constantly. It seems like every year there's more and more of that. So don't be surprised if there's something missing. And please stop me if you have questions. Okay, so we're going to start out with managed switches. So we have unmanaged switch and managed switches. An unmanaged switch provides plug and play capacity with minimal configuration options. So it has no IP address assigned to it. So for large networks, you're not going to see a whole lot of unmanaged switches because, you know, no IP address assigned to it. It's a little bit harder to mesh into a large enterprise configuration. Managed switches can be configured via command line interface, or a lot of them have web-based management GUIs. Switches are layer 2 devices, if you remember the OSI. However, the following higher layer switches also exist. So remember, multiple types of switches. There are layer 3 switches, and they are capable of interpreting layer 3 data, and they work like a router. There are also layer 4 switches, which are capable of interpreting layer 4 data. Switch path management. Okay, redundancy, that's something you should remember. They're going to see questions about redundancy a lot. So redundancy allows data the option of traveling through more than one switch towards its destination and makes your network less vulnerable to hardware malfunctions. A potential problem with having multiple paths through a network has to do with traffic loops. STP, or spanning tree protocol, prevents traffic loops. It's also called switching loops by calculating paths that avoid potential loops and by artificially blocking the links that would complete a loop. STP can also adapt to changes in the network, and it chooses the most efficient paths and calls these the least cost path. Okay, so this is just a nice little graphic here. So DP indicates downstream designated ports. RP indicates upstream route ports. So you see there's your route port, and there's your downstream designated ports right there. And you'll see this one is one that's been blocked because they are worried about looping. So STP information is transmitted between switches via BPDU, or Bridge Protocol Data Units. Some security precautions that must be configured on STP-enabled interfaces include BPDU guard, filter, and root guard. Newer technologies to improve or replace STP include the following: RSTP, or Rapid Spanning Tree Protocol; TRIL, Transparent Interconnection of Lots and Links; SPB, or Shortest Path Bridging. Some switch manufacturers have designed proprietary versions of STP optimized to work most efficiently on their equipment. When you use Cisco and you go through some of the Cisco stuff, you'll see slightly different things because Cisco likes to name everything after themselves. Switch port security. Unused physical and virtual ports on switches and other network devices should be disabled until needed. So basically, the reason that you do this is just to cut off more access that could possibly be configured incorrectly, or if it's just sitting there on default, which is another bad thing. If you're not going to use it, disable it. That's the general rule of thumb when it comes to networking or pretty much anything computer related. On Cisco, Huawei, and Arista, you can do shutdown. The no shutdown command on Cisco or Arista devices enables them again. Another Cisco command to secure switch access ports is switch port space port-security. It's a MAC filtering function that protects against MAC flooding. This type of switch port security is only one layer of the defense, and security should always be implemented in layers, which is called defense in depth. Now, there are some people that believe that defense in depth, because defense in depth is technically really old. Basically, it's like doing layer upon layer upon layer of different types of security, and there are a lot of ways in which it's not particularly effective against a lot of modern attacks. So there are different methods that have come up for security, but you'll see defense in depth mentioned a lot still. Okay, load balancers. A load balancer, and this is part of hierarchical design, helps to evenly distribute traffic to each device in a cluster, so every device carries a portion of the load. Cisco and other manufacturers have developed a hierarchical design for switches on a network called a three-tiered architecture. The access layer, or edge layer, consists of workgroup switches connected directly to the hosts. The distribution layer, or aggregation layer, is a highly redundant mesh of connections between multi-layer switches or routers. The core layer consists of highly efficient multi-layer switches or routers that support the network's backbone traffic. The flow of traffic between peers within a network segment is called east-west traffic. The traffic that must leave the local segment to reach its destination is called north-south traffic. Okay, so this is an example of three-tiered architecture, and this is switches at each layer optimized for performance and different function, and you can see there's your core layer, distribution layer, and access layer. This is another one that would be good to, keep the graphic of. As newer popular technologies, or sorry, I guess just newer technologies like virtualization, SDN, and cloud computing become more popular, east-west traffic began experiencing latency. A new hierarchical design was needed to better optimize the east-west traffic. Newer networks collapse the core and distribution layers into one layer called the spine. Spine switches on the backbone connect in a mesh topology with all leaf switches, but not with each other. This design is called a spine and leaf architecture and offers the following advantages: improved redundancy and scalability, decreased latency, increased performance and security, reduced expense. I always had an easier time remembering the spine and leaf architecture by thinking of it as a tree, which is why I think they named it that way. Okay, so these are the two architecture layers, provide more that I was just talking about. And you can see there's your spine layer and your leaf layer. Software designed networking, or SDN, is a centralized approach to networking. An SDN controller integrates all of the network's virtual and physical devices into one cohesive system. It relies on a form of abstraction called disaggregation. SDN abstracts the functions of network devices into different layers or planes. Infrastructure plane or data plane. This plane is made up of the physical or virtual devices that receive and send network messages, the control plane. This plane handles the decision-making process. Application plane, the SDN controller communication with network applications using APIs. And then management plane, this plane could be considered a part of the control plane. So usually with these, I just I do better with visual thinking, so I just draw them out so that I can remember them. So I'll look at these, and yes, I'll keep them, but I actually physically draw them out and label them just to help me reinforce in my mind. So there's your application plane, and then your control plane, infrastructure, and management plane. A SAN, or a storage area network. Do we have a question? APIs are application. It's what they're talking about when it's like application protocol. For some reason, I can never remember the I. Anyway, it's part of programming. It's like programming calls is what it's talking about. Let's see. There we go. So APIs, when it's talking about these are application calls to whatever, since this is all software based, it's an application protocol within the application plane to whatever that's trying to reach. So that's what it's talking about with an API. Does that make sense? Haha, thank you. Interface, application protocol interface. Thank you, Glenn. Yeah, so hopefully that makes sense. So yeah, anytime you see API, basically they're talking about a piece of programming that says, do this. Okay, so storage area networks. A network of storage devices that communicate directly with each other and with other portions of the network. SAN devices contain multiple storage drives and are designed to make data available to a network of servers. To maximize throughput, SANs rely on one of these networking technologies, either SD or fiber channel. This is a storage networking architecture that runs separately from Ethernet networks to maximize speed of data storage and access. FCOE, or fiber channel over Ethernet, allows FC to travel over Ethernet hardware and connections. Basically, Internet SDSI is a transport layer protocol that runs on top of TCP to allow fast transmissions over LAN, WAN, and the Internet. And then IB, which is InfiniBand, and this requires specialized hardware. The reason they do this is to move them outside of the rest of the network traffic so that so it doesn't get bogged down with the rest of the network traffic, and it allows just the data to move back and forth a lot faster. Does that make sense? Hopefully. So here's an example of a storage area network. There's your LAN, and then you have your fiber channel, SAN A, SAN B, and then you'll see your HVAs and file servers down there. Okay, so knowledge check. Which SAN connection technology can run over ordinary Ethernet NICs without any special equipment? A, B, C, or D. So FC, iSCSI, I'm sure that's SATA, and IB. I always feel bad calling it SCSI. I don't know why. So A, B, C, or D. Are we awake? Come on, guys. Ah, somebody's awake. You're waiting on peer pressure. A or B, B. So we're not really sure is what I'm saying here. Okay, so iSCSI. This works on twisted pair Ethernet or network with ordinary Ethernet NICs. FC requires special hardware. SATA cables connect a computer's hard drive to its motherboard. And then IB is that one that requires very specialized hardware. Okay. Virtualization. I love virtualization. It's one of my favorite things that's happened in the last 10, 15 years. This is virtual or logical versions of something rather than actual or physical versions. A host is a physical computer hosting a virtual machine. A guest is each virtual machine. A hypervisor creates and manages a VM. It also manages resource allocation and sharing between a host and any of its guest VMs. There are two types of hypervisors. Type 1 installs on a computer before any operating system is called a bare metal hypervisor. Type 2, this installs on a host operating system as an application and is called a hosted hypervisor. So the end part there is how you remember that: bare metal hypervisor, hosted hypervisor. To me, because I've built computers for so long, bare metal just meant bare. This is how you get stuff. And then hosted to me means that you have stuff already installed on it. So that would be how I would remember it, would be the end parts of those sentences there. Okay, and type 1 and type 2, there's examples of what they look like. So there's your type 1 hypervisor, and then you have your VMs. Now on this one, you see you have your host operating system, and then you have your hypervisor and your VMs. Yeah, I've used both. I've been lucky enough to use both. But most of the ones that I've seen were type 2. But I have seen a lot of switching to type 1. It just depends on what environment you're in. A VM software and hardware characteristics are assigned when it's created in the hypervisor. You can customize it with the guest OS, amount of memory, hard disk size, and processor type, and all sorts of other options. Sorry, I thought my phone was silenced. Okay, network connection types. So every VM has its own vNIC or virtual NIC that can connect to the VM to other machines. It operates at the data link layer. Each VM can have several virtual NICs. The maximum number depends on the limits imposed by the hypervisor. So some of the enterprise versions, they have a lot higher levels of virtual NICs that you can put in, versus the kind of like when you get the Windows Home versus Professional, you get more on the Professional than you do on the Home. It's kind of the same thing. When a VM's virtual NIC is selected, the hypervisor creates a connection that creates a connection between the VM and the host. The connection might be called a bridge or a switch. One host can support multiple virtual switches, which are controlled by the hypervisor. The way a virtual NIC is configured determines whether the VM is joined to a virtual network or attempts to join the physical LAN the host machine is connected to. Okay, so here's a graphic explaining. So you have your virtual switch, hypervisor, your physical NICs, and then you'll see your VMs and your virtual NICs on there as well. Bridge mode. In bridge mode, a virtual NIC accesses physical network using a host machine's NIC. It obtains an IP address, default gateway, subnet mask from DHCP server on the physical LAN. The VM appears to other nodes just another client or server on the network. NAT mode. In NAT mode, a virtual NIC relies on the host machine to act as a NAT device. It obtains IP addressing information from the host. The hypervisor acts as DHCP server, and this type of connection is appropriate for VMs that do not need to be accessed at a known address by other network nodes. And here's just a graphic of what that looks like. So you have your DHCP server, your physical network, your physical NIC, your virtual switch, and then your virtual NICs and your VMs. Yeah, I can see that. VMs running on bridge mode is pretty common on a lot of that. Host only mode. Okay, in host only mode, VMs on one host can exchange data with each other and the host. They cannot communicate with nodes beyond the host, which is why you guys wouldn't have been using host only mode. The virtual NICs never receive or transmit data with the host's physical NIC, which would cause all sorts of problems if you're trying to do anything that gets outside of that one. So this is just an example of how that would look. Okay, and we're going to go into the pros and cons of virtualization. So the advantages of virtualization: efficient use of resources, cost and energy savings, fault and threat isolation. It's simpler to backup, recover, and it's easier to replicate. Going to put a caveat there. It's simple to backup, recover, and replicate if you do it correctly. If you don't do it correctly, it's very easy to destroy an entire section of virtualized servers if you forgot to back them up. Then there's disadvantages. You can do compromised performance, increased complexity, increased licensing costs, and single point of failure. And what that means is if you have one box, one physical box that's got, and I'm just using a random numbers here. So say you have one box that's got 20 virtual servers on it, and that box fails, you just lost 20 servers. So that can be bad, obviously. But if you have backups of those, it would be easier to swap them over to another box if you have the hardware for that, and you can bring it up and hopefully not lose too much data when it happens. The biggest thing, the top two over here, efficient use of resources, cost and energy savings, are the reason that I see a lot of virtualization. To give you an example, the place that I worked previously, the school district, they did not have a whole lot of room for the physical hardware. So as they grew, the massive amounts of storage room were becoming a problem. So they started to go virtual to reduce their footprint, and you could just watch their power and cooling and heating and all, their costs just went straight down. And then you got to see, you know, we have this much, we freed up 3/4 of our physical foot space by virtualizing, as I think is where they eventually got to, and dropped a ton of costs by going to virtualization. So those two right there are usually where you see a lot of the temptation. Okay, network functions virtualization. So NFV is the process of merging physical and virtual network architecture. And you see this a lot now. Provides flexible cost-saving options for many types of network devices. So options for virtualizing network devices include the following. So we have virtual firewalls, which install a firewall's operating system in a VM on an inexpensive server. And then you have virtual routers. This installs a router VM on a server instead of purchasing an expensive hardware router. Some advantages on the network functions: virtual devices can be quickly and sometimes automatically migrated from one server to another in the event of hardware failure and for sort of maintenance. The resources are utilized more efficiently, and services can be easily scaled to meet the changing needs of the network. So if you have a firewall, just hardware piece, and you have a quickly growing need for your firewall, this is an example of something that you could do to go from like 100 to 1,000 a lot faster than you would with like a piece of hardware, because yeah, penny pinchers, they have a tendency they'll always find problems with no matter what it is. So, yeah, it's one of those you really have to balance the pros and cons with what you want your network performance to be and what the important pieces are to you. And you also always need to look at like the risk, is it okay for this much risk to be there? Is it not okay? That's where you come into whether or not you use hardware or virtual. Cloud architecture. So cloud computing is this refers to flexible provision of data storage applications and services to multiple clients over a network. Cloud computing features include on-demand service, broad network access, resource pooling, metered service, rapid elasticity. Storage capacity can quickly or automatically be scaled up or down. Okay, so this is cloud computing, cloud architecture. So there's your hypervisor, and then you have all your different stuff that's on there. And then you can see you can access this with your laptop, smartphone, tablet. So it might be a better use case than if someone was just using like one desktop thing instead of also using a whole bunch of different devices. They might consider this not the way they want to go. You don't know what they're going to use. Cloud computing service models are categorized by the types of services provided. So on-premise or on-prem, that's all hardware, software, and everything else is located and managed at the organization's location. IaaS, or infrastructure as a service, hardware services and network infrastructure devices are provided virtually, including end user interfaces like HVDs or hosted virtual desktops. PaaS, or platform as a service. Anytime you see the AAS, it means as a service. Includes the OS, runtime libraries or modules. The OS provides to applications and the hardware on which the OS runs. SaaS, or software as a service, applications are provided. That is the most common that is currently on the market. And then XaaS, or anything as a service. The cloud can provide any combination of functions depending on the client's exact needs. Cloud deployment models. So cloud services are delivered in a variety of deployment models. You have the public cloud. I can guarantee that you will see these on a test at some point. So remember these 5 right here. So you have your public cloud, which is service provided over public transmission lines. Private cloud, service established on an organization's own servers in its own data center. Community cloud, service shared between multiple organizations. A hybrid cloud, a combination of other service models into a single deployment. And then there's multi-cloud, a combination of the other service in a single deployment. Are there any questions on those before I get into the next slide? Yeah, thin clients for remote workers are something that that you see a lot, especially for large enterprises when they have a lot of remote workers. Okay, then there's orchestration and automation, IAC, or infrastructure as code. Is the process of using text-based commands in a computer-readable configuration file to create and manage cloud resources. This allows you to log changes made to your cloud resources. A programmed computer-generated response to a specific event is referred to as automation. As you convert more of your cloud maintenance and security tasks into code that can be run from scripts, you can automate many tasks to work together in a complex workflow, which is called orchestration. Connectivity and security. So potential risks and limitations include the following: ISP outages, ISP imposed bandwidth limitations, cloud provider outages, cloud provider backup and security system, misconfiguration that exposes one's client data to another client, unauthorized access to data by cloud provider employees or illegitimate users, breach of confidentiality, failure to comply with data security regulations, questions over ownership of intellectual property stored in the cloud, questions over data maintenance, and risk to the network, proprietary data, or customer information caused by BYOC. Ways to reduce risk of cloud computing include encryption, carefully choose the methods by which your network connects to your cloud resources. Consider the following: internet, VPN. A lot of places are slowly moving. I would like to see more of them moving faster to VPN, but VPN or virtual private networks, remote access connections, leased lines, and dedicated direct connections. Network availability. So availability refers to how consistently and reliably a file or system can be accessed. HA, or high availability, refers to a system that functions reliably nearly all the time. And you hear that a lot, nearly, because most of us who work in computers know that you can't say all the time, or the minute you say it, something will break. Uptime is the measure of time a system functions normally between failures. On a computer running Linux or Unix, view the uptime by using uptime. On Windows 10, uptime is found in your task manager. Next, we're on to fault tolerances. So fault tolerance is the capacity of a system to continue performing despite unexpected hardware or software malfunction. Failure is a deviation from a specified system performance level for a given time period. Fault is a malfunction of one system component. A fault can result in failure. The goal of a fault-tolerant system is to prevent faults from progressing into failures. So redundancy, MTBF, mean time between failures. This is the average amount of time that will pass for devices exactly like this one before the next failure is expected to occur. MTTR, or mean time to repair, the average amount of time required to repair the device. So this is just, would they do it kind of like a timeline? Well, I guess it's not kind of, it is exactly like a timeline. So here's your device failure, device repaired, device failure, and you'll see it like that. To help protect against faults and failures, networks are often designed with two or more of the same item, service, or connection, filling the same role on the network. If one part, service, or connection fails, the other takes over, or you can manually switch it over. The main disadvantage of redundancy is cost. People don't like to pay for it. So critical devices require redundant NICs, SFPs, power supplies, cooling fans, and processors. Automatic failover is the ability to immediately assume the duties of an identical component. Hot swappable refers to identical components that can be changed while the machine is running. Two approaches include the following: hot spare, a duplicate component that is already installed in a device and can assume the function in case the original component fails. And then a cold spare, a duplicate component that is not installed but can be installed in case of failure. Besides using redundant devices, you can do redundant links. So link aggregation or port aggregation is the combination of multiple network interfaces to act as one logical interface. So there's an example there, which is NIC teaming. Link aggregation allows for three major advantages: increased total throughput, automatic failover between aggregated NICs, load balancing, which is the traffic distribution over multiple components or links to optimize performance and fault tolerance. Okay, so link aggregation, and this is just it as it works. This is two workstations communicate with the server at the same time. And as you can see, that's just exactly what they're talking about here. Okay. LACP, or Link Aggregation Control Protocol, is dynamically coordinates communications between hosts on aggregated connections. Most of these services offer similar configuration options: static configuration, passive mode, and active mode. A load balancer is a dedicated device that distributes traffic among multiple computers. Clustering is the technique of grouping multiple devices so they appear as a single device. Clustering usually accompanies load balancing. A VIP or virtual IP address is used to represent the entire cluster. CARP, Common Address Redundancy Protocol, allows a pool of computers to interface or interfaces to share one or more IP address. This pool is known as a redundancy group. Okay, so here's your server load balancer, web server 1, web server 2, and that's an example of a web cluster. This is distributed switching centralizes management of the VM network connections. So here's your distributed switch, VM, host 2, VM. Okay, second, knowledge check activity. I don't expect you guys to absolutely know this one, but which is longer for a reliable device, MTBF or MTTR? Looks like everyone says B. A, MTBF, or mean time between failures, is the average amount of time that will pass for a device before the next failure is expected to occur. This should be significantly longer than the MTTR, mean time to repair, which is the average amount of time required to repair a device once it fails. I mean, yeah, it was a 50-50 shot, don't worry. Okay. That is it for today's lecture. Unless you guys have any specific questions about what we're going to be, courtesy of peer pressure. Yes, if you have any questions about what's coming up for the rest of this week, let me know. If you, otherwise, you know, everything's out in Cengage, and just go ahead and go forth and do your reading, do your labs. Remember, everything's due Sundays at 11 p.m. By the end of this week, you will see your groups, and you will see the exam, the assignment. Sorry, I was reading something and my brain went, huh? You will see the assignment stuff there too. So
I have one quick question.
yes, yes.
So you asked what we thought for the certs that might be helpful, and I was wondering, you know the job market better than us. Do you have any ones that we might want to look into?
I will say that it used to be more like certified ethical hacker, computer hacking forensic investigator, stuff like I have, but I'm seeing more of a shift towards the CompTIA certs. So like the CompTIA SEC Plus, Network Plus, you're seeing those as a more popular request for a lot of security jobs. So if you want to take any of the CompTIA certs, that would be the way that I would roll if you're doing any extra certs. So and then there are additional certs later on that are more advanced. There is what is the name of that one? It's got like a bunch of C's in it for so far. I can never remember it. 1 second here. It is, yeah, CompTIA is still listed as one of the top. CISSP, that's what it is. But that one, I believe you have to have a, like, either you have to have a bachelor's, like I believe you can do some education experience, but I believe you also have to be within the field for a certain amount of time before you can actually take the CISSP, and it is an extremely difficult certification. So give yourself time before you take that one. That is the, there you go. But yeah, the top 3 right now are the CISSP, CISA, and Security Plus or SEC Plus. CISA is the one that's through the government. And that one's another one that I would wait until after you've gotten a little bit more experience. I would get through your Network Plus, or not your Network Plus, Security Plus, and then look at the CISA and the CISP and see what they require. That would be my next step if I were you. Any other questions? Yes, no, we're good. Okay, all right, so take off, go do your stuff, stick around if you have any questions about anything else. Otherwise, you guys have a good night.